Welcome back to another Python for Beginners YouTube tutorial. This is Harry Does Data. I'm Harry Norton and I make data science videos here on YouTube. Today we're going to be taking a look at logical comparisons. Often we'll want to check whether certain conditions are true or false and then run different code based on these results. For example, this is a program that checks if a person is over 18 or not and then returns a different message based on those results. So first we define a variable as age equal to 19. And then we check, is age greater than or equal to 18? And if so, which in this case it is because 19 is greater than 18, we print this message, this person can buy alcohol. And if I run this, then you'll see that that happens. This person can buy alcohol. However, if we were to change this age to 17, then when we check, is age greater than or equal to 18, that would return false. And then the program would move on to the next part and print this person cannot buy alcohol. So if I run that, then you'll see that that's now the case. Now this overall code block is known as an if-else statement, and that's something we're going to look at in future videos. But for today, we're going to focus on this part, which is the logical comparison. This greater than or equals to is a comparison operator, and there are 6 comparison operators in Python, which we'll look through now. So let's get rid of our program here and we'll define 2 variables because comparison operators compare 2 pieces of data and then return only the values either true or false. So let's define our first variable as foo and have it as equal to 15, and our second variable as bar, and for now we'll have it equal to 12. And the first logical comparison we'll look at is the equal to logical comparison. So let's have a little print statement and we will print foo is equal to bar. And notice that the logical version of equals is the double equal sign, as the normal equal sign is obviously reserved for assigning the value 12 to a variable bar. Now remember, as I said, when we make a logical comparison, it will evaluate is foo equal to bar, and depending on whether that's true or not, it will return the Boolean value true or the Boolean value false. So this time around, foo is not equal to bar because 15 is not equal to 12, so we're expecting the Boolean value false to be returned when we run this program. And there we go. Now if we were to just quickly change bar to 15 and run the program again, then that should come out as true. The next logical operator you can use in Python is the not equals to. So not equals to is defined like this, and so we are checking that foo is not equal to bar. So let's just change this back to 12. And now 15 is not equal to 12, so this should return true, as it has done. However, if we were to change this back to 15 and compare 15 not equal to 15, then this should return false, as it does. Next up, we have the greater than comparison operator. So that is defined with this little right hand arrow. And if we run that with 15 and 15, then we should see false returned. So 15 is not greater than 15. However, if we make foo a bit bigger so that it is larger than bar, say 17, and run that, then we'll see it returns true. We also have less than, which is much the same. So is foo less than bar? 17 is not less than 15, so that returns false. But if we make bar a bit bigger to 20 and run that, then it returns true. Now closely related, but not quite the same, is the greater than or equal to comparison operator. So this does what it says on the tin really. It will check is foo greater than or equal to bar. So if we just run it at the moment, then obviously foo is not greater than or equal to bar, so it returns false. But if we change foo to 20 so that they are equal, then that will return true. And equally, if foo is greater than bar, then it will also return true. And very similarly, you have the less than or equal to operator, and I think you probably get the point by now. Foo is not less than or equal to bar if foo is 25 and bar is 20, so that returns false, and so on. Now, we will often want to compare multiple conditions to decide what piece of code to run. So let's just get another little example program in here. Let's just make that a bit bigger so we can actually see. So, in the UK, you have to be 17 or older in order to drive, but you also have to renew your driving license once you get to 70. Now this doesn't mean you have to do a new test or anything, you just have to send off a form to get a new license. But here's a little program that takes someone's age, checks if they are over 17, but then also uses this AND logical operator to check if they are also less than 70. So in this case, the person is 60, so they are greater than or equal to 17, and they are also less than 70. So in this case, this message would be printed. This person can have a driving license. So let's just run that quickly, and as you can see, this person can have a driving license. Now if we were to change this to say 75, when we do this comparison, we'd see that age is greater than or equal to 17, but we then check is age less than 70, and that is not the case. So this piece of code would be skipped. We'd move on to the next comparison. Age is greater than or equal to 70, and this is true, so we'd print this person needs to renew their driving license. As so. And finally, if the person was say 15, we'd see that age is not greater than or equal to 17, so we skip. We'd see that age is not greater than or equal to 70, so we skip. And we get to the final statement of this person cannot drive. Now, just as before, this entire block is an if-else statement and something that we'll come onto in a future video. But for now, we're concerning ourselves with these, the logical operators. These allow us to make two or more logical comparisons and will return true or false Boolean values based on this. So let's get rid of this again. There are two logical operators, and or. For an and statement to return true, both logical comparisons must be true. For an or statement to return true, at least one of the logical comparisons must be true. So let's start with and we'll define four variables. So we'll have foo is equal to 15, we'll have bar is equal to 12, we'll have one called faz as also equal to 15, and we'll have baz as equal to 1000. Now let's use an and logical operator to make two logical comparisons and see what the Boolean value returned to us is. So let's have a print statement. And first let's do two logical comparisons, both of which are true. So foo is equal to faz and bar is less than foo. So first we will check this. Foo is equal to faz and 15 is equal to 15, so that is true. Then we'll check bar is less than foo, so 12 is less than 15, and that is also true. So we have true, and overall this should return us true. Now, as I said, if either of these statements are false in an and statement, then the overall statement will return false. For example, foo is not equal to bar, so if we run that, then that will return false. If we return that back to foo equal to faz, and we do bar is greater than foo, 12 is not greater than 15, so that is false. So despite this one being true, the overall statement will return false. And obviously, if we have both of these as false, then that will also return false. Now the second logical operator is the or logical operator. And as I said, just one of the logical comparisons has to be true in an or statement for the overall result to be true. So obviously, if we have two true statements, then that will return true. So foo is equal to faz, correct, 15 is equal to 15, and bar is less than foo, so 12 is less than 15, also true, then this will obviously return us true. However, now we see, if we change one of these to become false, so foo is equal to faz is true, however bar is greater than foo is false, then the overall statement with an or logical comparison will be true. And similarly, we could have this the other way around, so we might have foo is less than faz, and bar is less than foo, so we have a false statement and a true statement, and this is true. And then finally, if both are false, so if foo is less than faz, so 15 is not less than 15, and bar is greater than foo, so 12 is not greater than 15, so both are false, and that will return overall false. Now you can have more than one of these logical comparisons in a row, so we could add another one and check is baz greater than faz, and if any one of these is true, then it would come out as true. So because we've now added a third thing that is true, even though these two are false, then that is true. So that is all for the logical comparisons tutorial. I hope you found it useful. If you did, please don't forget to give this video a quick like and subscribe to Harry Does Data so that you don't miss out on more great data science content.